Let's model some linear data with equations. Now, we've already talked in previous videos about slope and y-intercept, so if you haven't watched that, you might want to go back real quick and do that. So first, a linear model. They're simply equations used to predict values of independent or dependent variables when the change between the y values is constant. So we have to have a constant change in order to have our slope. You might recall that the slope-intercept form of an equation is y equals mx plus b, and the m value is the slope, the b value is the y-intercept, and that leaves x and y. Now, x and y are going to be any ordered pair on the line. Any of them. So when you're writing an equation, you want to keep x and y as simply x and y because they need to represent all of the points on the line. That's very, very important. Writing an equation means you are going to have y equals a number that represents the slope times x plus, also could be minus, a number that represents the y-intercept. Slope and y-intercept have numbers, x and y remain x and y. Let's do some of these. What equation would model the account balance shown in this graph? Well, we need the slope, we need the y-intercept. I said those backwards, but work with me. So the y-intercept is where our graph crosses the y-axis, and in this case, it's 0. The slope, we find that by saying, okay, from one point to the next, how much do I go up? So first we do vertical change. So point to point, I go up 5 and over 1. So the slope is 5 over 1, which is 5. So thinking about y equals mx plus b, in terms of m, I put a 5. In terms of b, I put a 0. So y equals 5x plus 0. That simplifies to just 5. Y equals 5x. Let's do another graph. Again, we must find the slope and the y-intercept. I always start with the y-intercept because that's usually the easy one from a graph. I know that y-intercept happens when the x is 0, so I go up. Y-intercept is 30. Now, to go from one point to the next, what happens? Well, I come from this point, and I have to go down 10 and then over 1. So my slope is negative 10. Again, I'm looking at y equals mx plus b. Substitute in what we know. My slope is negative 10. My y-intercept is 30. And that leaves me y equals slope times x plus 30. That's it. Y equals negative 10x plus 30. Final answer. Let's do another. Again, slope, y-intercept. I look at my, where's x 0? Okay, so the y-intercept here is negative 20. That's important. The negative is important. And going from one point to the next, what happens? How much do I move? Well, I go up 5, 10. I go up 15, so it's positive, and then over 1, so my slope is 15. I'm looking at my equation, y equals mx plus b, and let's substitute what we know. My slope is 15. My y-intercept is negative 20. So my equation is y equals 15x minus 20. You might also write it as y equals 15x plus negative 20, plus a negative and minus. Those are going to equal the same thing. Because in this second one, if you have plus a negative 20, that's the same as like plus 1 times negative 20, and a positive times a negative is simply a negative. And that is why they are the same. So either one of these would be okay. So let's use the equation for the PTK account. That was the last one we just did. Y equals 15x minus 20. So I'm going to write that down. Y equals 15x minus 20. We're going to use that to predict the balance for week 6. Now, remember that week, the weeks are the x-axis. So if it says week 6, that means x equals 6. Let's plug that in, right? We're going to substitute in, wherever we see the x, we're going to substitute in a 6. So y equals 15 times 6 minus 20. Remember that if a number is touching a variable, that means multiplication. So order of operations, 15 times 6 gives us 90. Y equals 90 minus 20, and y is 70. So we can expect if the PTK account balance continues to change in this constant fashion that it has been, then in week 6, the account would be, balance would be $70. Thanks.